Okay, good morning, everyone, and good afternoon. Actually, I should assume that I can safely say good afternoon because it is today Thanksgiving in North America and in the USA. So happy Thanksgiving if you're attending anyway, and if you're watching the webinar on YouTube. Welcome to the NAV Skills webinar, Git 101, the basics. Today we have Kamil Sacek with us, and he's going to explain to us how to start working with Git. Git has always been interesting, but it's extra cool now that we get a new development environment that has a native Git integration. So I actually asked Kamil if he could understand or make us understand the basics of Git. So a couple of housekeeping rules. The webinars are recorded. You can find them on YouTube. This is the link to our YouTube channel. New webinars can be found on the NAV Skills website. I have not updated it yet. I will do that once we start scheduling the next webinars. If you have questions, please use the GoToWebinar question window. Kamil prefers to have the questions at the end, which we typically do. But if you type a question that requires me to intervene, then I will do that if it makes sense. And of course, thanks for Rick being with us and Liberty Grove Software for using the GoToWebinar. Attention, next week we have a webinar, Job Queues to the Rescue, with Gino and Cynthia. So be sure not to miss that one. And then we have a quick list with webinars that we have in December and January. One thing that stands out, we have What's New in NAV on December 13th, which is one day after Microsoft is doing their show. We still think it may be interesting to attend Pike's webinar because we are going to give it a community perspective, maybe a little bit less cloud and maybe a little bit more about what has changed in C-side and functionality that has been changed and things to watch out for. So with that, I'm going to give the floor to Kamil. You should be able to share your screen, Kamil, and welcome.
Okay, thanks, Mark. I'm already sharing. It should be visible. Yep. Okay.
Okay.
Thanks. Hello, everyone. Welcome on this webcast about Git. My name is. Sorry. On the beginning, started on wrong slide. Git. The basics. My name is Kamil Sacek, and I'm Software Developer Department Manager at Navertica company in Czech Republic. I'm MVP since 2005, and I'm programming since 1985, which makes more than 30 years of programming for me. Today we will focus on the Git basics. We will go through what is Git at all. We go through some dictionary because we need to understand different names, words used together with Git. And then we will look at each function which we can use when using Git to maintain your version source controlled files. And then we will look on practical side, or we will demo each function in one sandbox environment. And at the end, we will look into VSCode, how the Git integration is done there, and how to use these functions to keep your source code safe and mainly managed. Okay, let's begin. What is Git? I use this definition from Git home website. It's really open sourced distributed version control system. And one good thing is that it's open sourced because it's really widely used. It means you are not alone when you have some problem. And it's used, I think, more than few millions users every day on the world. It means, yeah, we are not alone here. The main features is that you can use it without any server. You can start to using it on your computer without any other infrastructure needed for that. Of course, it will manage your source code locally only, but will give you every feature which is available inside it. It means really not depending on any server. It's good for beginning. Of course, you can use it with one or more servers. That's one feature which is very good in comparison with Team Foundation version control system, because it's centralized, but Git is distributed. It has some good sides of this. We can look at them at the end of the webcast. You can work fully offline without losing any functionality. It means you really can use Git when you are on airplane. You can develop without internet, and afterwards, when you are connected, you can just push your changes to the servers and go offline again. It has easy branching. We will look at what branching is, but for your quick understanding, creating branch in Git is nearly no cost, because it just creates some small file with 41 bytes inside it. It means creating branch and deleting branch is really quick and fast in Git. Git is fast and universal because you can use it on Linux, Windows, or other systems, and fast because if you want to manage all the source code for Linux kernel or something, it must be fast. I must say that I'm using it for our current NAV source codes, and there are more than 8,000 or 9,000 files in the repository, and we don't have any problem with speed when working with them. Okay, going from the dictionary. Git is the technology. In many cases, I've find out that sometimes it's hard to make difference between Git and GitHub. GitHub is online service for hosting your Git repositories. It means when you are talking about this, the SCM talk about Git, not the GitHub. GitHub is service only. We have local repository, which is some folder on your disk where are the versioned files and Git history placed. It's the workspace where you are working in VSCode, and all the files are inside that folder. There is nothing more around for the Git. Everything is inside this folder as a subfolders or other files. Remote repository is repository on server, which serves as a distribution point. It means you can, or anyone else with access to this server, can download, clone the repository to his local repository, and again put his changes back to this remote repository. You can have as many repositories as you want, and you can freely work with them and transfer the changes between the servers and so on. During the work with Git, we can hit word like index or stage. Index or stage area is an area where you can prepare the changes to be committed, to be saved into the history, into the Git repository. Again, we will return to that when we will look at VS Code and Git integration. But yeah, just you need to know that there is something like index and stage. You can find .git folder in the workspace in the local repository. That's the core of the Git source code management system. Everything which is creating local repository from the folder, which is used for saving everything to work with Git, everything is saved in this folder. It's hidden by default, but if you want to destroy the local repository, you can just delete this folder and Git is gone. It will be just regular folder and there will be no local repository anymore. It means .git, it's the core of the system. Git extension, source tree, and so on, that's our Git clients, graphical user interfaces for Git, because Git is based on command prompt commands. If you want to work with it in some visual way, those are the clients which you can use, and of course there are many others, and of course VSCode is one of them, but I must say VSCode is still limited in what you can do with Git inside the VSCode directly. And now the core words for Git: commit. We will talk about commits until end of the webcast, and we need to know what does it mean. Commit is a given snapshot of all the tracked files in a history. It means if we have some history here, from bottom to up, we go in the time, we started with some initial version, we do some changes and so on. Each node in the history is commit. As you know, commit from Dynamics NAV, commit is saving the data into table and making them permanent, these changes. Commit is same for Git, making the changes permanent in the history, in the repository, saving the information about the state of the files, about their content, and adding some additional attributes to this to let you know who did the commit, when the commit was done, and so on. Branch. Branch we can imagine as a named pointer to commit. It means when we have some commit, we have some snapshot of the files. We can name this commit with branch name, and then we can work with this branch. It means on the picture we have some history, and we have branch master, and we have branch feature one, and additional we can create them freely, and we work with them. We will see in practical examples how we can work with the branches. Tag is name or label for commit. It's nearly no difference between branch and tag, but branch is something which moves in the history, which moves to new commits and so on when we want. But tag is just fixed name or label for some commit. For example, here we have tag v0 as a version 0, and this commit is named by that label, and we can use this label when working with Git as a name of the commit. Head is again pointer which leads to active branch. It means head is telling us which branch is active now, and it's the point where the history will grow. It means here head is this triangle next to the branch name, and it is telling us the feature one branch is active now, and if I will create new commit, it will be added here on top of that branch. It means head is only one in each Git repository, and it's commit or branch which is active right now. Moving the head somewhere else will change the files in the workspace to the version which were in the commit we are moving the head to. It will be again better, more clear when we will start using Git. Stash, we have possibility to stash our changes which we did in workspace and stash them somewhere in temporary storage, do something with the files, change the branches and so on, and then return back to these stashed changes and continue work with them. Again, we will demo that in VSCode later. And I think last is a pull request, which is really a common word connection used, for example, when working with GitHub. A pull request is something you will use when you want to update branch, but you have no direct permissions to change this branch, and someone else must review your changes and accept them. It's very good, even when working with NAV, very good to use this pull request because you are using code review to check the quality of the code and so on. And pull request is a very good tool to keep high quality code in your product and teach your developers to code better and correct all different kinds of mistakes. Okay. Before we go to the sandbox environment, I will go through the functions we are using in Git. Sorry that I'm so formal on beginning, but we need to go and understand the different functions before we will look at the environment itself.
But that's why it's a Git 101 webinar, right?
Yeah,
and
exactly.
when people watch it on YouTube, they can skip forward. So
exactly.
Don't worry.
The first commands will be git init or git clone. Git init we will use when we want to create new empty local Git repository. It means it will create the .git folder in the folder from which we are creating the repository, and will create one empty new branch which is named master, which have no parent, no history, nothing. And we can start to use this workspace, this local repository to commit your changes and work with it. In comparison with git clone is cloning something from remote server. It means we have some repository which is on the distribution server, on the remote server, and we want to download this repository to our local system and start using it. You need to have URL for the remote repository, and then you will use the git clone to download it and start using it. Git commit. Each time you want to save the changes into the repository, you will use git commit command. It will save the changes, take the stage changes. Here we have the stage mentioned. You don't need to commit all the changes you made. You can say, okay, I changed 3 files, but I want only commit changes in one of these files. Then you can, this file, move to the stage or index, and the commit will take only this file and save the changes in this file to the history, to the Git repository. Commit is snapshot. Git is saving differences between the different commits. It means it will not save all the content of the files you changed. It will save only the difference. It means the repository is not growing so fast, and it's very quick when you want to switch between the historical version of the file. Of course, it's very quick. Committing repository with 8,000 files, it takes only a few seconds. You are done. Each commit have few attributes. One main thing is unique hash. Hash is 40 character string which identifies the commit uniquely. You can work with this hash in a way that when you want to put somewhere the hash number or hash, you put only first X characters which are unique from this hash. If there is only one commit, you can put only first character, and it will be enough for Git to understand which commit you mean. Each commit have description, which describe what's inside the commit. In the description, it's on you to find some good format of the description for each commit, because you need to have the main information here to see, for example, work item number to which this commit is connected, these changes inside this commit, or other features like if it is bug fix or some new feature. There is an author of the commit, date and time when it was done, and of course each commit have parent and child commits, because when you are merging and branching, you need to keep tracks which commit is following which one. Git checkout. Git checkout is function which moves the head to selected branch. It means when on the picture, when I do git checkout feature 1, it will lead to situation we have now. The head is on the feature 1. If I do git checkout master, the head will move to the master. And in my workspace, I will have files with content which was saved in the commit, which is now pointed by the master branch. It means checkout is moving the head and is updating the files in the workspace to selected saved snapshot. It means it will rewind all the changes to specific commit. You can, of course, check out any commit. It doesn't need to be a branch. You can directly check out commit between branches or anywhere. It's named detached mode, but I don't or try to not use it. But for example, TFS, when you are building your objects on TFS, TFS is working in this detached mode. It means you need to understand what detached mode is. It's head which is leading directly to the commit without any branch. Git branch command git branch will create new branch in a point where the head is heading now, when the head is pointing. It means if our head is on a feature 1 on this commit, git branch feature 2 will create new branch on same place here. It means it creates the pointing branch, and it's connected to the commit on which we are now with the head. An active branch, and the branch is not active until we check out the branch. It means we need to use the previous command to say, okay, now activate, move the head to this new created branch. As I told already, branch is a small file, 41 bytes, which only have the commit hash inside with end of line. That's why there is 41 bytes inside. When you commit changes, the active branch pointer is moved to the new commit. It means if I create new commit, the active branch will move to this new commit. It means the branch is growing in a point where the branch was, the active branch, the head was pointing, and really this pointer is moving to this new commit. Git fetch and git pull, those are commands we are using together with remote repositories. Both are for the direction from remote to local. It means from the server to the local host, to the local repository. Fetch will only transfer the changes which are on the remote and we don't have on the local. It means it will download the new commits which are on the remote server. It will transfer all the remote branches. It means it will show you where the branches are pointing right now on the server. And fetch have no effect on local branch or head. It will not change them. It will be still same. That's different with a pull. If we use the git pull, it will do the fetch. It means it will download all the changes from the server and will do something which is named git merge. Again, we will talk about that later. It means it will move our local branch to the point where the branch should be because some remote changes were downloaded. It will be clearer when we look at that in the sandbox environment. Here, it's a situation where we started the git fetch. It downloaded one commit which is new on the remote server. The remote branch here is named oric/master. Oric is name of the remote server or remote connection, and master is the master branch on the remote server. It's new. We didn't have it before. Our local branch master is still on the same commit we have it before that. If we use git pull, it will do fetch, download again the new commit, but then it will move my local master branch to this point where the remote master branch was pointing. It was not move it was merging my commit, which was before marked as a master. It will merge this my local master branch with the remote branch oric master, but because it's a successor of my branch, it just move the branch here. It will not do anything complex. Git push, it's a command in opposite direction when we want to upload our changes from local repository to the remote repository. If the current branch I am on is not connected to remote branch, which is already on the server, it will create the remote branch for my local branch. It will do something which is named publish in VSCode. Yeah? Publish means create my local branch on the server and show this to other users that there is a new branch which can be used. It will transfer all my local branches to remote repository. It could be set up how it works. You can push even all the branches or only one selected. It's on you. And it will, if there is a conflict, because someone else already pushed changes to the same branch, I need to solve this conflict, because my push will be rejected by the server. Server will tell me, okay, sorry, we have something newer here you don't have in your branch. First merge it or solve that and then push again. It's on you to solve these conflicts. It means who is faster in pushing the commits to the server have no additional work. If you push after 1 week and your colleagues made 20 commits and push them on the server, you need to merge your changes with all these changes first before you push your change. And git merge, you know the merge from when merging, for example, NAV versions. Git merge do basically the same thing, but it merge 2 branches together automatically. Of course, if there are some conflicts which Git cannot auto-solve, it's on you to solve these conflicts and continue in the merge. There is one big difference with merge when merging manually. Git knows how the changes were done in both branches and will merge only the changes which were made from the last merge. It means because all the history is clear for Git, it will take, for example, only last 2 commits which were not merged yet, and only these changes will be transferred. You don't need to find these 2 files in 8,000 files which you need to merge. Git will tell you which one you need to merge. And Git Rebase. Git Rebase is a tool which allows you to cut the branch you have and plant it on top of some second branch or another branch. It means it will move your commits which are not merged yet and replay the changes on top of another branch. Rebase is very good tool, but it's dangerous because Rebase is changing the history of Git in some meaning of that. During the Rebase, you can squish your commits into one. It allows you to, for example, if you will have feature branch and you are developing one feature, but you did 20 commits during the development, it allows you to change these 20 commits into one and apply this one new commit off top of your master branch, for example. It's on the picture here. We have a feature branch with 2 commits, and Rebase to the master will take first commit and replay it on top of the master, take second commit, replay it on the top of the previous one, and that's new branch feature you have. It means you just cut the branch here and plant it on top of new commit with new changes. From that, there are big discussions on Git communities if you should use a rebase or merge when you are in conflict. You can use merge if you want the history as it really was. You don't want to change the history in the Git. Then you can use merge when you are merging the changes with some changes from your peers. You can use rebase if you want to see how the app evolves. It means I have an app and there was added new feature 1, feature 2, feature 3, and I doesn't care about the history itself, how the feature was developed. It results to nearly linear history in the Git, but you are losing the reality in the Git repository. This is the example. We have master branch. We develop feature C3. Sorry, and we merge the feature with the master. It will create C6 commit. We can see that it was created by taking these two branches together and creating new commit. If we use rebase, it will take the C3 and create new commit, which is based on C5 and is doing the same changes which were in C3, but it's just replayed on top of the master. The result is same. The C3 dash is same like C6. The result is same, but the history in Git repository is different. We are losing the history here, not in the merging. Okay. Last one, Git cherry pick. As the name is telling you, you can use this command when you want to take some existing commit and apply the same changes somewhere else. The Git cherry pick creates the delta for the commit with the previous commit. We'll take this delta and apply this delta, this patch, to some other commit. You need only solve the conflicts if there are some, and you can commit the new version of your files. Cherry picking is very good tool when you want to take one particular change from somewhere and replay the same change somewhere else, and you don't want to do full merge or something like that. Okay, going for Git 101, we will use learning Git branching environment for that. Okay, that's our environment. Here we have a graphical representation of our Git repository. Right now we have two commits in our repository, C0, C1. We have one branch, master, and the head, the asterisk here, is on the master now. On the left, we have a console, which I will use to type the Git commands, and we will see how the repository will evolve. If I use Git commit, it created new commit in the history. It means I did some changes in some files, I did Git commit, new commit was created, and the master branch, because it is head for us now, was moved to this new commit. Again, and now I can use Git branch, and I will create new branch here. Git branch added new pointer to this commit, F1, and I am still working with the master branch here because the head is still on the master. If I want to switch to F1 branch, I need to use Git checkout F1, And you can see that the asterisk now is on the F1 branch. It means when I will do git commit, the new commit is added, but the master branch is still on the same place, but branch F1 is moved. Now I can switch back to master branch. Head is now on the master. And if I now commit some changes, the master will move. And now we have two branches which are different because we have different changes in both. I will add one commit to the master. And now I say, okay, I want to merge my changes from feature 1 branch to the master. I can say, okay, git merge if1. A new commit was created, which is a result of merging changes from both branches. I will go one step back. In opposite, when I use the rebase, I will switch to the git checkout F1. I will work with F1. I want to, for example, in feature 1, I want to use some changes which were made in C5 or C6 change because I need it for my feature. And now I can merge master into my branch, or I can rebase my branch on top of the master branch to include all these changes. I will use the git rebase master, and what that will do, it will take the C4 changes and do the same changes on the top of the C6. It means we have now commit C4 dash as a branch F1, but still you can see that there is a hidden commit C4. Git is not deleting commits, it is creating commits because you want to have all the history. It means the C4 is there, but it's not visible because it's not marked by any branch or tag. If we have tag on the C4, it will be still visible because there is no tag or no branch which will keep it visible. The commit is hidden, but still I can go to this commit by git checkout C4, and it will move my head to this commit, and I can work with it. For example, create new branch to keep it visible. I will switch to F1 again. The C4 commit will be deleted when something like a garbage collector is used for the repository. This tool will clean up the repository from such lost commits and will save your space on the disk. Okay, that was how it looks when we are using commit, checkout, rebase, merge, or creating branch. Now we will show how it looks when we are using the remote repository. First, I will do git clone. It means now we have remote repository and local repository, which one master branch, which is connected to remote master branch. I will do git commit here. I will do git fake teamwork to add some commit on the remote repository because someone else did something and pushed the changes here. But we don't see the C3 on our local repository. If I do git fetch, it will download the change and display this change even in my local repository. And now I can see that my master, local master branch, is not same as a remote master branch. I need to merge these changes or rebase my master on the top of this remote master to be able to push the changes. If I use this git push now, it will tell me it's rejected because it's not same. It means if I do git merge o master, it will merge it, and now I can git push, and these changes will be uploaded to the remote server, and now I'm okay. This is the work with the remote repositories: push, pull, fetch. Okay, that's all from this simulator. I will go back to the presentation, and we will look at Git in VS Code. There is a native support for Git in VS Code, but you still need to install the Git itself, because it's not part of VS Code itself. VS Code is not so visual with the Git, like this environment show us the history and so on, or other clients which you can use, but you can use many extensions to make it better. VS Code is good for the basic operations like commit, branch, push, pull, and merge. If you want something more, you can use the extension or any other client for doing that. Okay, going to the VS Code now. I have VS Code. Yep.
If people are interested, there is a video on our YouTube channel that explains how to install the Git and connect it to VS Code. Yeah.
Okay. We will look at how the VS Code is using the Git. First thing is for us, we have tab here, which is showing us source control Git, that we have already Git in this workspace, and the repository is inited and already with some history. On the left button, we can see that we are on the feature 1 branch. I can change the branch by clicking here and selecting, for example, master branch. You see that automatically the file was changed to the version which is active now under the master branch. Or I can git checkout to feature 1, and we are back on the feature 1, which have another message on the line. The best feature of the Git for me is that I can see here directly who changed the line last time. It was me 2 days ago. I committed the change with the commit message check message, and I can see that the line was in this form before I replace it with this form. I can go directly. Yep.
So we never have to comment code anymore. Never, ever.
Yeah, exactly. You don't need it because you see the commit message. You can see who did it, why did it, when did it, and you can go for details more directly from VS Code. Yeah. If I move somewhere else, I see that its initial version, it was not changed. Even here, I can change how it's displayed and see the commit message for each line, which was changed. Of course, this is part of extension. What I am showing you this information. Yeah, but what I know in VS Code update, which was published, I think, today or yesterday, there are some changes about which information are directly accessible from here. It means Microsoft will add these functionalities maybe as a native things.
Yeah, they tend to do that with extensions, right? They look at them and say, "Oh, that's cool, and let's make it ourselves."
Exactly. If I do some change here, for example, my command, save the file, even here, that's the one new feature in VS Code, native feature, is that I can click on this bar and see which changes I have in comparison with last commit. It means what I did from my last commit. I added this file. Okay. I can revert the change easily, or I can directly stage the change to be prepared for commit. Or I can go here, oh, sorry, and I see that I changed this one file. When I click on it, I see I edit one line here. I can again discard the change or say, okay, stage this change, I want to commit it. Now this change is in the stage area, and I can tell or input only the message. And I can commit. The change was saved, new commit was created. I can see that I changed this line a few seconds ago. It's saved as a commit 5.6 blah 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 with some message. Because this branch is not on my remote server from which I cloned this repository, I have this small icon here, which tells me that I can publish the changes. It will push my branch to the remote and make it available for other people to use it. I don't want to do that right now. I will switch to the master branch. And now in master branch, I see that I have different icons here. I have these two arrows, which tells me that I could synchronize the changes. And I have number 1 and arrow down, and number 2 arrow ups. It means I have one change on the remote server which I didn't download, one change in the master branch, and I have 2 changes in my local repository which are not on the server. It means I need to push 2 commits to the server and download or pull 1 commit from the server. When I do that, when I do the synchronize, it will pull the changes from the server, merge them to my local branch, and if all is okay, it will push all the changes to the server. As you can see, everything was done without any conflict. The change on the server was that there was new file which was downloaded. It means no conflicts during that. If there is conflict, VS Code will show you the original version, new version, and you have directly buttons to accept one change or another or both, or you can manually edit the result and then commit the merged result. That's the easiest part, how to work with the Git. Just mark the changes, commit them. Of course, if you want more, under the menu you have all the functions: pull, push, rebase, commit all or only staged, and so on. You can easily undo last commit. If you committed something and you want to return back, you just use the undo last commit, and it will create new commit which is undoing all the changes. It means you can see now it started untrack my new file because I added this file. It is trying to remove this file from the repository. That's the easiest work in VS Code. Thanks for some extensions. We have even things like Git view history or branches, which will give you this visual look on the history. You can see the branches here, the commits with all the information and how it was created. There are other things to visualize the information needed, but I think it's outside scope of this webcast right now. I will return back to my presentation. Before we go to Q&A, I have one thing which is interesting, and I will use for that another client, because it's much better to understand what we can do. I will open one repository I prepared here. It's repository, oh, sorry, it's wrong one. Because the distributed system, because Git is distributed, you can connect one workspace to multiple remote repositories, and you can use that in case when you want to merge between repositories. For example, here I have two remotes. One is a repository with NAV code, NAV standard objects, which I'm keeping with all the cumulative updates. And one repository is for our product. I can clone, for example, the NAV repository, the standard versions, and I can manually add another remote here for our product and download all the commits for the product, and then I can merge between, for example, cumulative update. Sorry, here is NAV 2017 Czech version, latest version I have, and if I want update our product, I can just tell, okay, merge this branch from different remote, merge it, and our product will be automatically upgraded. And then I push the branch for our product to the product repository. It will automatically include all the commits from the NAV vanilla repository and push that to the remote server. It means you are not limited by one server. You can, or one repository in one workspace. You can use multiple repositories in one workspace and merge between the branches, and only the relevant commits for relevant branches will be pushed to the repositories as you will tell which branch goes where. Yeah? That's just for you to imagine possibilities of that. Okay, going back to the presentation, and I'm ready for Q&A now.
Sure, perfect. We have one question in the question window. First of all, Kamil, thanks. This was a really clear explanation and some really cool demos. So I'll give people the opportunity now to type the questions in the question window, and the first one we have is, which extension are you using for Git on VSCode? So what extra stuff are you using?
Okay, here's on the tip page I have. I'm using the Git history, Git log extension to graphical display of the history. I'm using the Git lens, which gives you the history, commits, and other things, and mainly the information on the line, who changed the line. I think it's part of the Git lens. Mm-hmm. I'm using the Git merger, which helps to merge with merging, because you can set up some additional options when merging. And one Git add remote, if you want to add the remote repository URL to your existing local repository, because there is no standard way how to do that in VS Code. This extension will add this possibility. And now I am using even Git extensions extension, because it's extension which is allowing me to use Git extensions GUI together with VS Code. Because if I am here and I want some functionality which is not in VS Code but in Git extensions, I can use Git extension, for example, blame current file, and it will automatically open it in the Git extensions client, and I can do whatever I want here. Because I am using Git extensions for last 2 years. It means it's good for me that it is connected with VS Code.
Yeah, and I think we should mention that we already talked with you and Gunnar about doing a follow-up webinar where you go into the more advanced stuff that you guys created, right?
Yeah, I think it will be mainly Gunnar, because Gunnar just finished his extension for VS Code to use his Git Advania tool.
Yeah, okay, cool. We have one question, but we are out of time, but let's see if we can answer this question.
Yep.
What is a good branching strategy? When should one consider to create a new branch instead of just committing everything against the master?
Yeah, I think this is really a question which have no one answer. The branching in Git is so cheap that there is many strategies you can use. For example, the feature branches, hotfix branches, together with staging branch and some QA branch and live branch or something together. I think it's best to go through all these discussions about branching on internet, and you will make a picture for yourself. There is one thing you can look at. It's named Git Flow, which have again some extensions into VS Code. Git Flow is one strategy you can use for branching, and it have tools which make it easier for you, because there is, for example, command to create new feature, finish the feature, or create new bug fix, finish the bug fix, and it will do all the merging and everything for you. Yeah. But branching is really wide subject.
I think we have another follow-up webinar here. We are completely out of time, and we are getting more questions now on branching. So I think we should do a follow-up webinar on that. So thanks, Kamil, for doing this. Thanks, Rick, for being in the background as always, and see you hopefully next week.
Pleasure.
In the other webinar. Bye,
Okay,
everyone.
thank you.
Bye.
Bye.
You bet. Kamil, thank you.
You're welcome.